Okay, so today we're going deep on GStreamer.
Ooh, that's a big one.
It is. It's a
Yeah.
big one. And, if you're doing anything with streaming media,
Okay.
like if you're building an app or a tool that works with audio or video or really anything that streams,
Hmm.
GStreamer is like the framework you got to know.
Yeah, it's super powerful.
It is. And it's kind of inspired by the way video pipelines work.
Okay.
You know how video gets processed in stages?
Hmm.
GStreamer takes that idea and runs with it.
Interesting. So it's like a chain of operations, each one handling a specific part of the stream.
Exactly. And it actually shares some concepts with things like direct show.
I see, I see. So for this deep dive, we're using the GStreamer 1.7.90 manual as our main source.
Yep. We're going to crack this manual open and pull out the core ideas, the essential architecture.
Right, the nuts and bolts.
Yeah. So our listeners can really grasp what makes GStreamer tick.
And how to actually use it.
Exactly. We're approaching this from a developer's perspective.
Cool.
Someone who wants to build stuff with GStreamer.
Okay, so let's start with the fundamentals. The manual talks about GStreamer's clean and powerful design.
Right. Clean and powerful. What does that even mean?
Well, it's about creating a system that's both elegant and efficient.
Okay.
And a big part of that is its object-oriented nature.
So it uses objects to represent different parts of the system.
Exactly. Which for developers means you get reusable components and a really structured way to build complex pipelines.
So it's not just a random collection of functions?
No, it's much more organized than that. And then there's the extensibility through plugins.
Right, plugins.
You can add all sorts of functionality just by dropping in plugins.
And these plugins can be pre-compiled, right?
Absolutely. So
Yeah.
you don't always have to build them from scratch.
Yeah.
And this plugin architecture is a huge part of what makes GStreamer so versatile.
So if I need to support a new audio format or a funky video codec,
Chances are there's already a plugin for it.
or I could write my own.
Exactly. You got it.
Yeah.
But here's the thing. Even with all this modularity,
Yeah.
GStreamer is built for speed.
It's not just flexible, it's fast.
Exactly. The manual digs into this and highlights several factors.
Like what? Give me an example.
Well, for one, it uses glib's gslice allocator.
G-slice allocator. Say that 5 times fast.
I know, right? But seriously, this specialized allocator is all about efficient memory management,
Okay, so less overhead, less fragmentation.
which translates to smoother playback and lower resource usage in your application.
Especially important for real-time stuff.
Absolutely. Then you've got the lightweight links between plugins.
Lightweight links.
Think of it as minimizing the processing that happens when data moves between stages.
So instead of copying data all over the place,
You're often just passing pointers.
so it's direct and efficient.
Very much so.
Yeah.
And there's more. The manual mentions direct memory access.
Okay, this sounds interesting. Tell me more.
Imagine a video decoding plugin writing straight into the graphics card's memory.
Oh, okay.
Or an audio plugin sending data directly to the sound card buffer.
No unnecessary copying.
Exactly. You got it.
Yeah.
This direct access cuts down on bottlenecks and leads to much better performance.
Lower latency, too, I imagine.
Absolutely.
Uh-huh.
Especially for things like games or live streaming where every millisecond counts.
Right. And then there's reef counting and copy on write.
Ah, yes. More clever tricks to optimize data handling.
Explain those to me.
Reef counting is basically a way to track how many parts of the pipeline are using a piece of data.
Okay.
If multiple elements need the same data, you don't have to copy it for each one.
You just share it.
Right. And copy on write is similar. It ensures that you only create a new copy of the data if you're actually going to modify it.
So you're not wasting memory on duplicates.
Exactly. You're catching on.
Yeah.
And to keep things running smoothly, GStreamer uses dedicated streaming threads.
Dedicated threads.
Yeah. Separate threads managed by the operating system to handle the actual processing.
So your app doesn't freeze up while it's crunching data?
Exactly. It can stay responsive even when dealing with heavy multimedia streams.
That's smart. And the manual also mentions hardware acceleration.
Right.
Okay.
Certain plugins can tap into the power of your GPU or other specialized hardware.
To speed up things like video decoding or encoding.
Exactly. Offloading those tasks from the CPU can make a huge difference in performance.
Especially for high-resolution content or complex effects.
Definitely. And finally, to keep things snappy, GStreamer uses delayed plugin loading.
Delayed. What does that mean?
It means it only loads the plugins you actually need when you actually need them.
So it doesn't waste time loading everything at startup.
Precisely. It only brings in the components that are essential for the current task.
Makes sense. The manual also emphasizes the clear separation between the core and the plugins.
Right. That's another key design principle.
So the core handles the fundamental pipeline management.
Yeah, moving data around, managing the state of the pipeline.
And the plugins are responsible for understanding specific media formats and doing the actual processing.
Exactly. So if you want to add support for a new video codec,
You just need to write a plugin,
right, you don't have to mess with the core GStreamer code.
which is probably a good thing.
Definitely. It keeps things modular and maintainable. And finally, the manual talks about GStreamer as a framework for codec experimentation.
Okay, so it's not just for using existing codecs.
No, you can use it to develop and test new ones.
Interesting. So if I had a brilliant idea for a new way to compress video.
GStreamer would give you the tools to try it out.
Awesome. Okay, so we've established that GStreamer is clean, object-oriented, extensible, and fast.
And it has this clear separation between the core and the plugins, which makes it really flexible.
Right. But what are the actual building blocks?
That brings us to elements.
Elements.
Think of elements as the individual workers in a GStreamer pipeline.
Each one has a specific job to do.
Exactly, like reading from a file, decoding audio data, sending output to your speakers.
And you connect these elements together to form a pipeline?
Right, like a chain of processing steps.
Okay, but how do they connect?
That's where pads come in.
Pads.
The manual uses a great analogy here, comparing them to the jacks on a home theater system.
Okay, so like audio jacks and video jacks.
Exactly. Each element has these pads, which can be input or output points.
And just like you wouldn't plug a speaker cable into a video jack?
GStreamer pads have restrictions on the type of data they can handle.
So there's this concept of caps negotiation.
Right before two elements can start exchanging data, they need to agree on a format.
Resolution, bitrate, all that stuff.
Exactly. They negotiate these capabilities, or GC caps, to ensure compatibility.
Which happens automatically behind the scenes.
Yep, you don't have to handle it manually.
That's nice. Now, the manual also mentions dynamic and request pads.
Yes, those are special types of pads.
What makes them special?
Well, most pads are always there, but some elements can create new pads on the fly.
Like when?
Imagine a demuxer. It takes a media file and separates the different streams.
Sounds like the audio and video tracks.
Right. So a demuxer might start with just one input pad for the file.
And then create new output pads for each stream it finds.
Yeah, exactly. Those are often called sometimes pads because they appear when needed.
Okay, what about request pads?
Those aren't created automatically. You have to explicitly ask for them.
Like if I need an extra output from an element.
Exactly. The manual gives examples like multiplexers.
Which combine multiple streams into one.
Right. Or T-elements, which split a single stream into multiple copies.
So if I wanted to send the same video stream to both a display and a recording element?
You would request a new output pad from the T.
Interesting. So elements are the workers and pads are how they connect and negotiate.
Exactly. Now let's move up a level to bins and pipelines.
These sound like ways to organize a bunch of elements.
You got it. A bin is essentially a container element.
You can group a bunch of linked elements inside a bin.
And then treat that whole group as a single unit.
To manage complexity.
Exactly. And the manual says bins also manage the state of their children.
So if you tell a bin to start playing,
all the elements inside it start playing as well.
Makes sense. And bins also handle the flow of messages.
Right. If an element inside a bin encounters an error,
that message can bubble up to the application?
Via the pipeline's message bus.
Gotcha. Now, a pipeline is a special kind of bin.
Right. It's the top-level container for your entire media processing flow.
So what makes it different from a regular bin?
Well, for one, it provides that crucial message bus.
So your application can receive notifications from the element.
Yeah, exactly. Errors, end-of-stream signals, metadata, all that stuff.
And it also handles synchronization.
Right. Making sure all the elements are working together smoothly.
Plus, it runs in its own thread.
Keeping your application responsive.
Okay, so we build our logic with elements, connect them with pads, organize them into bins.
And the whole thing is orchestrated by a pipeline.
Which also provides a communication channel.
Exactly. And that brings us to the third key concept, communication.
How the application talks to the pipeline.
Right. The manual outlines three main methods.
Let's start with buffers.
Buffers are the containers for the actual media data.
The audio samples, the video frames.
Exactly. They carry the raw data downstream through the pipeline,
the low source to the sink,
so to speak. Then we have events.
Events are more about control information.
Right. Things like seeking, pausing, end of stream.
And they can travel both upstream and downstream.
Exactly. So buffers are the what, and events are the how.
And finally, we have messages on the bus.
The message bus. This is a key way for elements to communicate asynchronously with the application.
So if an element encounters an error or discovers some metadata,
It can post a message on the bus.
and the application can listen for those messages and react accordingly.
Exactly. It's a way to handle things out of band without blocking the main processing thread.
Okay, so we've covered GStreamer's core design, its building blocks, and its communication mechanisms.
It's a really well thought out framework.
It is, and as we've seen, it's capable of much more than just basic playback.
Right. The manual touches on things like dynamic pipelines, metadata handling, and synchronization.
All areas we could explore in more detail in future deep dives.
Definitely understanding these fundamentals is just the first step
To unleashing the full power of GStreamer.
for building all sorts of amazing multimedia applications.
So here's a final thought for our listeners to ponder.
Okay.
Given this modular design of GStreamer with its elements, paths, and pipelines, could you see these concepts being applied in other areas beyond just audio and video?
That's an interesting question.
Like, could you imagine using it to process streams of sensor data?
Oh, I see.
Or building custom analysis pipelines for completely different types of information?
It's certainly possible. The underlying principles of connecting processing units and managing data flow,
Right.
those could be applied to a wide range of problems.
It's really a framework that encourages you to think about data processing in a new way.
A modular and flexible way.
Well, on that note, we've reached the end of our deep dive into GStreamer.
It's been a fascinating journey.
It has. Thanks for joining us, and we'll see you next time for another deep dive.
See you then.
Bye. Bye.